Density and volume. We're first going to talk about density. What is density? Many of you can tell us that density has to deal with water, and that it also has to deal with sinking and floating. But why does this happen? Density is the measure of the mass of a material in a given volume. What that definition is saying is that density is a measurement of how solid something is. Basically, you're looking at the mass of something per the volume of it. And basically, the volume is just the space the mass is taking up. Two things contribute to density. The first one is the mass of the atoms or molecules that make up the material. The second one is the volume or the amount of space the material takes up. If the molecules or atoms are packed closely, it will become more dense. Stop. Just stop. Stop and think about what was just said. A lot of information was thrown at you, but now it's time for you to infer what density means. Here are two pictures of elements. This is how they would look on the periodic table. Right here, you'll see each of their masses that they have. Helium's mass is much lighter than gold's mass. The atom's masses have a ton to deal with when it comes to density. The more massive the atoms or the molecules, depending on what you look at, the denser the object will be. Now let's look at the other part. Let's look at these two objects. Here you have helium balloons, and over here you have gold bars. The second part in looking at these objects has to do with the space the atoms take up. The space the atoms take up in the balloons is going to be much less than what the atoms take up in these gold bars. The more mass we have with those atoms and molecules and the amount of space they take up is going to give that particular object its density. Now here's a good example to explain everything we just went over. Styrofoam molecules have less mass and there is more space between them. Now compare those molecules to a brick, where the molecules have more mass and they are packed closely together. Here's the formula for density. Its density equals the mass divided by the volume. You'll need to know this formula. And here's what it's expressed in. Depending on what you're looking at, it's either centimeters per cubed or milliliters per cubed. Now we're going to take a look at volume. Big question is, what is volume? We touched upon it before, but honestly, what is it? So volume is the amount of space that matter occupies. Everything that we know has volume, including solids, liquids, and gases. Volume is expressed in meters cubed, centimeters cubed, liters, and milliliters. When the question was posed in class, what volume is, many of you were able to tell us how to find the volume of a regular object. In this case, we're going to say rectangular. Rectangular or squared object is what is considered to be a regular object. So, for rectangular volume, the formula is just volume equals length times width times height. And here's your units. You'll have the centimeters times centimeters times centimeters equals centimeters cubed. And this was stated before. Do not forget to put centimeters cubed. See how there's 3 centimeters there? So if we wanted to find the volume of this object, we'd have to multiply the object's length times its width times its height. So let's pretend that it is 12 centimeters long, and it is 5 centimeters wide and 6 centimeters tall. So we take our length and do 12 cm times 5 cm times 6 cm, and that would equal 360 cm cubed. Okay, don't forget about the cubed, the cm cubed. I know how much we hate putting units, but the cm cubed tells us that we had those 3 cm's there, so it's our length times width times height. Now this was the one thing that we had a hard time with remembering from way back when in 6th grade, on how to calculate the volume of irregular objects. So you have to measure the irregular objects in a different way. You submerge the object in a graduated cylinder. That liquid will rise by the amount equal to the volume of the object in milliliters. This picture shows 2 graduated cylinders. These 2 graduated cylinders are going to be used to help find the irregular volume of this rock. The first cylinder shows the initial volume. This means that you poured water to an initial amount. In this case, it happens to be 50 milliliters. The second cylinder is showing the final volume. If we look over here, the final volume is at 75 milliliters. The final volume includes the rock in it, in that particular cylinder. So what do? We're going to take our final volume over here and subtract it by our initial volume over here to find the volume of that rock. So we have 75 milliliters because we got that from our final volume, minus 50 milliliters from our original volume, which gives us 25 milliliters. And that's the volume of our rock. Please make sure you use this presentation to help you as you complete your lab and other problems that you have with density.